Dear friends, today I start the lecture 14 of Math 304. We start with one another transportation problem. I have given you the information about three methods. Then the further one we use theta, that is known as Modi method. Here 21, 16, 25, 13, 17, 18, 14, 23, 32, 27, 18, 41. All these are cost coefficients. And this is demand supply 11, 13, 19, demand 6, 10, 12, 15. Means it is 24 and 19, that is 43 is supply, and 6, 10, 16, 12, 28 and 15, 43 demand. Means supply and demand are the same. Then I teach you three methods. The first one, that was minimum northwest corner rule. So by that method you can use 6. So this 6 is over, then I use 5. Now this is over, so then again 5, this is over, then 8, this is over, then 4, 12, and then here it is 15. So both of they are over, and therefore here the cost of transportation is 126 plus 80 plus 90 plus 108, sorry 112, then 72, and then 41 into 15 that I have to calculate by some method, and that will be 615, and therefore this sum is 5, 11, 20, 21, 7, 28, 29, 3, 4, and 1095. This will be the answer for transportation problem by northwest corner rule. As I shown the same in the previous lecture, north, south, this means we have to start with this, means it is 126, 80, 90, 112, 72, and this is 41, 410 and 205, means it is 5, 1 and 6, 1, 5. So this is 6, 10, 5, 15, 11, 9, 20, 21 and 8, 9, 2, 3, 4, 109. This will be the answer. Then the another method which I teach you, which we have discussed in the previous lecture, I have to draw the same, and that is, I think you know that the second method is minimum cost entry method. So first I have to write the same table here: 21, 16, 25, 30, 17, 18, 40, and 23. That 27, 18 and 41, and the supply 11, 13, 19, and demand 6, 10, 12 and 15. Now I start with minimum cost entry method and try to fulfill the requirement. Actually friends, I have not made this calculation in my note, but as this is a second sum, I am doing it for all of you students. So minimum one is, see there, which one the minimum one? First I have to show that I have 21, 17, 32, 16, 18, 27, 16, 18, 27, 25, 14, 18, 25, 14, 18 and 13, 23, 14, 13, 23, 41, 11, 13, 19, 11, 13, 19 and 6, 10, 12, 15, 6, 10, 12, 15. So data is okay. We have transferred the actual data which we have available. Now we start with the minimum entry, which I think if we have the minimum one is 13. Anything less than 13? I think no. 13 is the minimum. So maximum possible flow is 11 and we exclude the other entries and therefore this is done. Now 4 remain there because already the supply of 11 was done. Now minimum one is 14 and therefore there is possibility of 12 and therefore this is done. And now one is remaining. Now the minimum one among remaining is 17. I think 1. So this is done. Now this the last one is remain and therefore we have to do the flow there. Means it is 6, means it is 5, 10, 15 and obviously 4 and therefore it is 19. So how much it costs us? So the cost of transportation by this method, let's calculate. 13 into 11, 143, 17, 140, 168, 160, 270 and 41 into 4 and that is 164. Yes, it is 164. So the answer is 10, 8, 11, 18 and 4, 22. So 2 is the 4, 6, 7, 14, 20, 27 and 6. 27 and 6 means 33. 4, 5, 6, 7, 8, 9. Let's calculate once more. 10, 8, 18. 4, 22 means 2. 6, 7, 14, 20, 27 and 6, 33. 4, 5, 6, 7, 8, 9. Means it is better. It is better. Better than the previous one. And the last method. So this is minimum cost entry method. And the next method which I would like to share with you, that is Vogel's method or penalty method. So I delete all this previous data from this one. So the next method is Vogel's method, or I say penalty method. And for that, so 932 I write this value somewhere here, and that was the previous values was much higher than this one. Now in this method we are going to find the solution by Vogel's method, and for that we used to find the first minimum and second minimum, means it is 13, and 16 means it is 3, 14 and 17 means it is 3, 18 and 27 means it is 9, here it is 4, here it is 2, here it is 4, here it is 10. So maximum penalty is this 10. So we pass maximum possible flow over here, because this is demand, this is supply. So 15 is demanded and supply is of only 11, and therefore we can pass here only 11. Therefore now this will not be in any calculation, so this is done. In the next one, so these penalties are remain the same, but these penalties are different. It is 15, it is 9, it is 4 and 7 and 11 means it is 18. And therefore here is this one the minimum one, and therefore we can pass 2. We have no idea, not more than 2 there. And therefore, because so I can pass it 4, because we have 15 means this is done. Then among remaining, this is done. And now we have 9 available. Among remaining, the first minimum, second minimum, it is 4, 3, 9, 15, 9 and 4. So 15 is the maximum one, and this is minimum one. Possible, I think 6 is possible. We have 6 is possible. This is 4, 9, 9 and 4. Means we have tie right now. But if we choose this 9, we can apply here is what? We can give 3. And there is no another way. And if we choose this 9, we can give. 12. So if I choose this one, I can give 3. 7 and 6 means this is done. Now here it is 7, here it is 12, so it is 90. And therefore the solution will be 143, okay, then 102, then 54, then 92, then 27 into 7, how much? 189. Six. What will be the sum? 6, 5, 9, 11, 26. 2, 6, 5, 11, 20, 28, 29. 3, 4, 5, 6, 7. 796. Much better. And by this method, it was near about 900. By the first method, it was more than 1000, and now it is less than 800. And this is much better. But I have to calculate it once more. 5, 9, 11, 20, 26, 2, 6, 11, 20, 28, 29, 3, 4, 5, 6, 7. Okay. 796. So these are the answers. Now I want to check that whether these values are optimal or not, or we have to apply Modi method, means that theta method. For that I have to eliminate all this previous work which I have done here. And in that method, I have given you the idea. Only consider those values, those basic variables in which we done some flow. This one, this one, this one, and 23, 27, 80. Means, as you know that number of dots should be 3 plus 4 minus 1, means dot should be m plus n minus 1, means 3 plus 4 minus 1. That is 6 we require, and you would know that 6 are there. So with this note, I would like to stop this lecture here and continue the same lecture after few minutes. Please, as this is online lecture, you can see it and at your convenient time. But now I want to confirm that whether this is optimized or not. Optimized means it is not possible to find the another solution there or try to find solution there. Clear? Okay, I stop with this lecture. See you in the next lecture. Thank you very much.